Thank you, Chairman, for introducing me. I am Sung-Chul Chun, working at Incheon National University, Korea. The subject of my presentation is concrete breakout strength of anchors under shear and compression. Upwardly installed anchors are subjected to shear and tension. The actual tension reduces the shear strength. So ACI 318 has adopted this interaction curve for design anchors under shear and tension. How about compression? Does it decrease or increase the shear capacity? We know that the axial compression increases the shear strength, especially the bearing pad in bridge pier are subject to heavy compression force from superstructure. Unfortunately, the ACI 318 did not consider the favorable effect of compression on shear strength of anchors design. So this study was conducted to evaluate the enhanced shear strength of anchor under shear and compression. ACI 318 defined three kinds of failure of anchors under shear. Among three design strengths, the smallest strength is determined as the nominal strength. If reinforcing bars are placed around the anchor reinforcement strength can be used instead of concrete breakout strength. If the pryout strength and steel strength are sufficient, the nominal strengths are determined as the ratio of concrete breakout strength and anchor reinforcement strength. The nominal strength of concrete breakout and anchor reinforcement strengths can be calculated using these equations. This equation was developed from CCD method. In CCD method, the mean strength is 1.8 times the nominal strength. So we can predict the maximum load of test using these two equations. Let's think about shear strength of compression member such as columns. The shear strength is enhanced due to the compression, and this effect has been verified through numerous tests. The enhanced shear strength of compression member can be explained theoretically using modified Coulomb yield criteria. As the normal stress increases, the shear strength also increases. Similar situation occurred in bearing pad of bridge. So the main purpose of this study is to experimentally evaluate the enhanced concrete breakout capacity of anchors under shear and compression. A total of 30 specimens were tested across the A series. Each specimen has two anchors of 60 millimeter diameter. The main test variable is axial compression up to 3.5 times the concrete breakout strength. The other test variables include the existence of anchor reinforcement, H distance in the direction of the applied shear, and the H distance in the direction perpendicular to the applied shear. You can see the test setup. The axial force was applied using two centaur type hydraulic ram. The constant axial force was maintained during test. A monotonic shear force was applied. It's photo of the test setup. It's a typical unconfined specimens. The red dotted line represents the expected failure surface. There was no reinforcement across the expected failure surface. It's a typical confined specimens by anchor reinforcement. At the top of the specimen, the horizontal bar were placed at 6-inch spacing. According to the ACI 318, only 5 bars were effective as anchor reinforcement. Test result. You can see the cracks on plan view after test. Each column shows a single series of test group. The top shows the specimens with no compression force, and the bottom shows the specimen with the greatest axial force in the series. As you can see, there was no significant difference with varying axial compression. You can see the comparison of unconfined specimen and confined specimens. All 8 specimens had the same details except the existence of anchor reinforcement. The left column shows the cracks of unconfined specimens. There was a few cracks. The first crack occurred like this, and mainly governed the failure. However, in the confined specimens, relatively many cracks occurred. The first crack is very similar to the first crack of the unconfined specimens, but as the load increases, another cracks occurred in this area. And at the failure, these cracks governed the failure, and it was not the first crack. So it means that the anchor reinforcement properly confined the cracks. Let's see the load displacement relations. The left graph shows the unconfined specimen, and right graph shows the confined specimen. The red lines represent the specimens with the greatest compression force in the series. In both series, as the axial force increases, the maximum load also increases. And the confined specimen shows the more ductile behavior than the unconfined specimens. The increased shear capacity were plotted with the bearing axial force. X-axis represent the applied compression force normalized by the concrete breakout strength VCBGO. And the y-axis represented the measured maximum load normalized by VCBGO. As expected, as it increases the applied load, the maximum load also increases linearly. The red line represents the regulation of all specimens failed by concrete breakout. The right graph shows the load of specimen failed by anchor reinforcement. For 6 specimens, the anchor reinforcement strength governed the failure. The load was enhanced earlier, but the increment of the anchor reinforcement strength due to compression force was only 6%. So, for safety, it is recommended to ignore the incremental due to compression force for anchor reinforcement strength. So we can predict the enhanced shear strength using this equation. The riser of the VCBGO plus 0.75 times the compression force and anchor reinforcement strength. This graph shows the comparison of test to prediction. The average and coefficient of variation of test to predictions are 1.04 and 16.5%. The COV value is comparable to that of the CCD method, from which the ACI 318 code was developed. Conclusion. The concrete breakout strength of anchor in shear can be enhanced by axial compression. The increment of the concrete breakout strength is 75% of the axial compression, on average of 60 specimens. The anchor reinforcement strength increased slightly with axial compression. From the test result, an equation to predict enhanced shear strength by axial compression was proposed. The COV of the test prediction ratio of 22 specimens is comparable to that of the CCD method. Thank you for your attention.
Thank you.